Hello everyone. In this video, I will talk about the Riemann sum. So the Riemann sum state that if we have a continuous function, so for example, the function look like this, and from A to B, so from x equal A and from x equal B, and the question is we want to find the area under the curve, this area, but there is no particular formula that allows us to calculate this formula. So people come up with no method to calculate this area. They will cut this area into multiple pieces, multiple rectangle. So this is the first rectangle. Okay, they cut it. We cut it. 3 rectangle. We have 4 rectangle. We have 5 rectangle. We have 6. Okay, so we cut it into multiple rectangle, and if we calculate the sum of all the area of the rectangle, we will end up with the area that approximately the area under the curve. So if we see that there is an empty space here, right? Empty space here. If we have more rectangle, the empty space will be filled up, right? Will be covered up. So if we have, instead of 6 rectangle, if we have like 100 rectangle, like 1,000 rectangle, we will, like, our calculation will be more accurate. Okay, so the area of the rectangle equal to, okay, so these rectangle have the same width. Okay, all of them have the same width, and the height is f of x. Okay, so this is the first rectangle, right? We calculate the area of this first rectangle, and we add up with the area of second rectangle, and the third one, the fourth one, the fifth one, and the sixth one. We add them up. Okay, so the area of the first rectangle is fx1 delta x, right? And fx2 is the second rectangle, is the height of the second rectangle, and the width, plus, and to the f x6, right? To the f of x6 delta x. Okay, so because we have 6 rectangle, the area of all rectangle is like the area of the 6 rectangle. But if we have n rectangle, we have like n rectangle, it will be the summation of I from 1 to n, f of xi delta x. So this, I write this formula as a summation notation. So if we have n rectangle, our calculation will be more accurate, right? So if we have 1,000, 10,000, an infinite rectangle, those empty area will be covered up. So the total of the total of area of the rectangle will be approximately the area under the curve. Okay, so this one is, we will take the limit when n go to positive infinity, right? Of I equal 1 to n. F of xi delta x, because we want to get an infinite rectangle, right? So this formula is called the Riemann sum. Okay, so by the definition of integral, the definition of integral is the Riemann sum. So this limit of the summation, the Riemann sum, equal to the integral from a to b of fx dx, right? So the Riemann sum actually is the integral of the curve from a to b. So whenever you want to find the area under the curve, you just find the integral of the curve from a to b. Okay, so next one, we will go through an example to make sure that you get familiar with this topic. Okay, so we have to find the area under the curve of this function over the interval from 1 to 3. So first of all, we will draft the function, all right? So this is y, this is x, y and x, right? So if you want to graph the quadratic function, you have to find 4 points, okay? So first, I will choose when x equal 1, we will find f1, okay? X equal 3, f3. And minus 1, f minus 1. And minus 3, f minus 3. Okay, so x1, 2, 3, negative 1, negative 2, negative 3. Okay, so when x equal 1, right? 1, 2, 3. When x equal 1, f1 equal 2, 3. 1, 2, 3. This is 3. So this point, right? And when x equal 3, right? X equal 3, f3 equal to 11, right? So it's up here. It's up here. So this point. Okay, and when x equal -1, we have to find f minus 1. So this is -1, and f minus 1 is 3, this point. And f, and this is -3, and f -3 is also 11, this point. Okay, so when x equals 0, f of 0 equal to 2, right? So this point. So we draft the function. I will connect this 5 point. Okay, so this is our function we have. So we have to find the area under the curve over the interval 1 to 3. So when x equal 1, x equal 3 here. So we have to find this area. If you want to find the area under the curve of this function, you just compute the interval from 1 to 3 of x squared plus 2 dx. Okay, and then if you want to find the integral, you just find the antiderivative of it. So the antiderivative of x squared is x cubed over 3 plus 2x, right? 1 to 3. And then you plug in 3 to this function, and then you plug in 1 to this function, and you take the expression of it. So this is 3 cubed over 3 plus 2 times 3 minus 1 over 3 minus 2, right? So this is equal to 38 over 3. So if this video is helpful, don't forget to like and subscribe for my channel. Thank you so much.